Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Rabbi shrahli sadri wa yassirli amri wahlul 'uqdatam min lisani yafqahu qawli. Allahumma aftah alaina hikmataka wanshur alaina min khazaini rahmatika ya arhamar rahimin. Alright, so we will learn about Laplace transform today. So this is the last part. So the mini topic is solving differential equations. Okay, so previously we have seen this formula. Okay, basically if you have the differentiation of a function xt in time domain, okay, so you can convert to Laplace transform by just change the function xs multiply by s. Okay, so if it's a first degree, so you just convert once only, but if a second degree or third degree, you have to change this one to 2, for example 2, and then there is a s xs and so on plus the initial conditions. Okay, so to solve the differential equations, that means if we have functions or system that need a differentiation, okay, we will convert it into an algebraic equations. How? By transform it into S domain or frequency domain using the Laplace transform. Okay, so this is function xt. The effects or the frequency the response is a differential equations, okay, and it will become t, and then we will use the frequency domain analysis from frequency domain to time domain, okay, using the inverse Laplace transform. Alright, so for example, we have a function xt. The function is xsi multiplied by esit. Okay, the frequency response hs will be regarded, okay, as the system response to each of the exponential components in a way that the output yt. So that means that if you have the functions xsi es1t as the input, okay, the yt will be dependable on the frequency response hs multiplied by the input. Okay, so that means the input equivalent to the system response multiplied by the input response. Okay, let's say that we have a differential equation as a system. That means the system response is a differential equations, and then we will convert it using Laplace transform to solve the functions ys to find the system response ys divided by xs. So this is the main goals, to find the what is the output divided by the input. Okay, so if we have 2 second derivative of y minus 3 first derivative plus 5y equivalent to 10 first derivative minus 7x. Okay, so this is in the time domain t. Okay, so in frequency domain, we know that if we convert the differentiation, it will become, this is second, right? So s squared ys multiplied by the constant minus 3sys, okay, the second one, and then 5y become 5ys. So the input part 10 first derivation 10s xs minus 7 xs. So this is the Laplace transform. Now we want to solve what is the hs, system response, equivalent to ys divided by xs. So you will just factorize ys here and also the xs. Okay, now it will become 10s minus 7 divided by 2s squared minus 3s plus 5. Right, so if the functions give you initial conditions, okay, so this is the second derivation. So we want to convert into algebraic equations. So now it will become s squared. Okay, so this part is equivalent to this part. Okay, that means we have to consider the initial conditions. Okay, the initial condition is given by v at time 0 equal to 1, and the first derivative at time equal to 0 is minus 2. Okay, so this is from the table. Okay, d squared vt over dt squared is equivalent to second derivation s squared vs minus sv s multiplied by the initial condition sv and minus v prime of the first derivative at time equal to 0. So this is stated in the table. So this whole set is equivalent to this part. And then the second one, 6 first derivative svs minus the first initial condition, or the v at time equal to 0, which is equivalent to 1, plus 8vs. So this is straightforward from this one, equivalent to 2ut. Okay, according to the table, ut is equivalent to 1 over s. So this is it. So now we have changed into frequency domain. Okay, now we substitute the values of first derivative, initial condition, and also the second one, and then we put the value already and substitute the initial conditions, and then we proceed with the what is the vs. Okay, vs, so you factorize the s. Okay, and here is at the right side, so you rearrange and then you will get these equations. Okay, so now to convert it into time domain, you have to partially convert into, or part by part. Okay, a over s plus b over s plus 2 plus c over s plus 4. Okay, we will convert this one to time domain, this one into time domain, and this one into other time domain, part by part. Okay, now we want to find what is a, b, and c. So we use this step. So you just take out the s and put it as equivalent to 0. So you just remove this part to this side. Okay, and then substitute the values 0. So you will get 1 over 4. And then the second part s plus 2, and you take it back the first part just now, and then you substitute the roots. What is the root here? S minus 2. In here, s minus 2, s minus 2. So you get b as 1 over 2, and also c, the third part here. Okay, now it left with s and s plus 2. Substitute the roots s minus 4, and you get the value of a, b, and c. Now we have the value of a, b, and c, and we know that 1 over s. Okay, we know what is s plus 2 and s plus 4. Okay, so for this one, we know that is a shifted value. Shifted value of what? Of 1 over s, 1 over s, and 1 over s. So 1 over s to convert into time domain is ut. Okay, so ut is 1 over s, and then the shifted is -2, and -4. So we know that this is the property of the Laplace transform, and then this is factorized of each of this one. Okay. Right, one more example. Now we have integrations and differential, differential equations. So, I mean we have differential and integrations. So dy over dt plus 5yt plus 6 integration of y tau d tau equivalent to ut, and it also gives you the initial condition. Now we want to change this one to Laplace and this one into Laplace. Okay, with its initial condition value, and this one is straightforward. So now become SYS, the first one, okay, from this part, the differentiation, and plus 5YS, the second one, and then the integration. Okay, for if differentiation we multiply by S, in integration we divided by S. Okay. Okay, equivalent to 1 over S is the UT, okay, without any constant or shifted values. Okay, so again, we substitute in the initial conditions and factorize the YS. So now we will find A and B because we want to do part by part. Okay, find the value of A by substituting the root of the S equivalent to -2 at here, and you got the -3, and also B. Substitute and convert this one, and it is the answer. Alright, so now we can easily convert to time domain. So the 1 over S is a UT. The shifted value will be represented by an exponential. Okay, so just now we learned about what is transfer function or system response by defining it as the YS divided by XS. Okay, the output divided by the input. Okay, the HS or frequency response also can be applied into V out over V in, or I out, current divided I in, or also impedance V over I, or also the inverse of impedance I over V. It can be any combinations depend on the requirement of the system, okay, what they want to know. Alright, so if input is a delta t, impulse response, okay, so in frequency domain, delta t is equivalent to 1. So when you multiply 1 by Hs, okay, it will become Yt multiplied by Ht, if that it's a delta. Okay, so this is the inverse Laplace. Okay, so another example is Yt equivalent to tan e minus t cos 4t ut. That means this is a causal system. The input is e minus t ut, also causal. So find the transfer function Hs, okay, of the systems and its impulse response. Okay, so we just substitute the e minus t into frequency domain, and then the tan e minus t cos 4t ut. Okay, so how do we know that cos 4t ut? In the S, we refer to the table. Okay, so we change into this form. Okay, so this is actually you can refer to the table, and then you find what is YS and XS, substitute, and then you can solve the system transfer functions. Okay, so and then what happened? We convert into HT to find the impulse response. In time domain, you just simplify this equation into part by part, and then you can convert into time domain. Okay, and this part from sine. Okay, the next one we learn about what is a block diagram in transfer functions. Okay, if you were given this kind of block diagrams, that means this is the transfer function. This is the input and also the output. Okay, so the output will be equivalent to the system response multiplied by the input. Okay, we also have a cascaded system where from another output become an input to another system. Okay, so that's mean we consider this one the input Rs multiplied by the system response. So this one will become the input x2 to the second one. So we multiply G1 Rs multiplied by G2 and then become the input to this one and multiply again. So this is cascaded, means this input cascaded into this output cascaded into this one, become input and this one. Also, if the system having a parallel system where it's actually the first system RSG1, the second one RSG2, and the third one RSG3, and then this is the multiplier. Okay, so the multiplier will combine all the response and multiply by the RS. So we factorize it and now it become the cascaded system. Okay, after we simplify. We also have a feedback system. In control system, usually we have a feedback system. So this is a closed loop where we have the input transducer coming to this one and actuating signal. So this is the gain, or we call it also the system response. The first one, and the second one at the plant, we have the second response. Mean this one give different impact, this one give different impact. But part of the output will become the feedback of this multiplier. So if you want to combine this one, so now it become HS, and combine this response become GS, okay, and HS. So the feedback we always write as 1 plus GS HS here, because it will have to consider the GS, and the GS will become the main system response, and this one is the feedback. Okay, so in this example, we have summing junctions where the first feedback here, the second one, and the third one. So that means we have to consider different input at the multiplier as a feedback of the system. Okay, so this is the system response. So for the first one, G1, we just multiply here G1, G2 and G3, but at the feedback we will consider 1 plus, simplify this one, G3, G2. So this is the response of these summing junctions. Alright, so for this chapter we will stop until here, and after this we will continue to the new chapter, inshallah. Okay, so we finish with tasbih kifarah and surah wal asr.